Okay, we're going to take a look at section 9.3 and we're going to continue with our study of measurement, converting. This time we're going to focus on weight. Last time we looked at length and area. This time we're going to look at weight. We'll look at the customary or US system. We'll also look at the metric system. And then we'll look at temperature, because although at least in our country we tend to use the Fahrenheit scale, in science they use the Celsius scale, and in other countries I think they use the Celsius scale. It sort of fits with the metric system better. So some of this, a lot of this, will be very similar to what we've already done. When we're talking about weight, and I'm not going to get on my soapbox about calling this weight, because the metric unit of a gram does not truly measure weight. It measures mass. If we were in a physics class, this would be a huge difference, because the mass is the quantity of matter that you have. And mass doesn't change whether you're here or you're on the moon. Your weight is a measure of gravitational force on the mass. So if you weigh something on Earth and you weigh something on the moon, they're going to be different. Weight depends on gravitational force. Mass does not. We make kind of an assumption that weight and mass are the same thing. In physics, they are very, very different things. In everyday language, though, we tend to treat them like they're the same. So your textbook calls this a study of conversion of weight units. Kilograms don't measure weight. So that is actually an error, but it's a common error. So we'll go with it. You can see the prefixes are the same that we used when we dealt with metric units in length. We have kilo, hecto, deca, then we've got whatever unit. We're going to use a gram for weight, and then deci, centi, and milli. And so all of that is familiar. We're going to use the same little slide scale that I drew. The paper clip, a small paper clip, really does a good job of helping us wrap our minds around the metric system a little bit. This is the small paper clip, not the big one. The width is about 1 centimeter. The thickness of the wire is about 1 millimeter. And the weight, that's an error, but the mass of it is about 1 gram. So the paperclip's really nice to be talking about things in the metric system, because it ties together the unit of mass and the unit of length. Okay. You can see the same little slide scale that I had yesterday or the last class, and the little mnemonic device that I use, different than what your book has, is King, Henry, dances, that's the DA, then whatever your unit is, double, circles, merrily. That's just my memory device for remembering the order of those. So we're going to jump right in. I doubt that we need to do all of these, but just to show you, it says convert the given unit of weight to the unit indicated. So we're in the metric system, just the metric system. And when we are, we can make our little scale. I'll make the middle one a little larger because that's for unit of gram. Then K, H, DA, D, C, M. In my head, I was saying that little sentence. All right. I'm supposed to start at decigrams and move to milligrams. Start at decigrams, move to milligrams, and I am stopping right here. So that is how many moves in which direction? 2 to the right. So I will pick up the decimal point in my given number, 6.6, and I will mimic that and move its decimal place 2 to the right, dropping it here. I fill in with a 0, and my answer is that I have 660 milligrams. just like yesterday. So it didn't matter that we changed over to a different concept. We're talking about weight or actually mass. But using the metric system for conversions is the same. Let's do just a couple more. I don't think there's any reason for me to take a lot of your time with this because it is so similar. All right, I'm dealing with grams. I need to convert from milligrams, tiny, tiny, to grams. Still tiny, weight of a paperclip is a gram, and there are 1,000 milligrams in a gram. So we're talking grains of salt. All right, so kg, hg, dag, dg, cg, mg. All right, I am converting from milligrams to grams. That's 1, 2, 3 to the left. So I'll just make that note. And I mimic that with the decimal point on the given number. I have 940. Where is 940's decimal point? Since it's a whole value, it starts on the right. I need to move it 3 to the left. I'll go around 1, 2, 3. That's its new home. It is 0.940 grams. And I hope that you recognize that you could leave that last zero off. Zeros that are behind the decimal and trail mathematically don't need to be written. The only time they're important is when you're doing technical measurements, and 0.94 and 0.940 imply a different accuracy to a scientific or technical person. To us, they're the same number. All right. Would you do, I'm skipping a few because I don't think we need to do them in the video. They're all done on the lecture notes, but I'm going to pause the video, and in class, would you do number 5? All right, hopefully you've had an opportunity to do this one. Let's do it together, and then that'll probably be enough review on the metric system. All right, we're dealing with grams. kg, hg, dag, dg, cg, mg. Really messy. There we go. All right, I'm going from milligrams to grams. From milligrams to grams is 1, 2, 3 to the left. So I will take my given number. I'll write it so it can be read. Pick up the decimal and go 3 to the left. 1, 2, 3. Drop the decimal. Fill in with zeros. And this is 0.0000018. It is customary to see that zero in front of that, and like I said in another lesson, that's just like an alert, here comes a decimal point. I just make big decimal points, so maybe I don't have to do that, but you'll always see it in print in a book. All right, everybody good with the metric system? All right. Now, let's do some. That was metric. Now let's do it in our customary US, sometimes called English, system of measures. And we're going to switch between the two systems. So I've got each one of these questions pops up with some conversion facts. And here in class, hopefully you've still got your conversion facts. You're going to need that for your first test in class. So that and other handouts, we'll talk about it as we prepare for the test. All right, the first one. Use the given equivalents along with dimensional analysis to convert the given unit to the unit indicated. All right, this is in our system. It is 33 ounces changed to pounds. First thing I need to do is have a fact. Switch back to black. And probably don't need to recopy it. It says 16 ounces equals 1 pound. So how do I do it? Dimensional analysis. Start with the given, 33 ounces, and put it over 1. Please put the unit on there. That's what helps you. Multiply it by the fact turned into a unit fraction, a fraction that's equal to 1. You want ounces to cancel out, so I will put my 16 ounces on the bottom and my 1 pound on top. I know I'm doing it right because the ounces cancel out. And that gives me 33 times 1 is 33, 1 times 16 is 16, and the only unit left is the pounds. Now I'm going to read these instructions right here. They're in blue, and it says round to the nearest hundredth as needed. So I know it wants a decimal answer. On my calculator, I do 33 divided by 16. I get, whoops. All right, I got 2.0625. This is pounds. Nearest hundredth, the hundredth is the 6. And the 2 tells me to leave it alone. So my answer is approximately 2.06 pounds. Is that okay? Just like yesterday. The conversion is no different. All right. I guess we can go ahead and do that next one. It doesn't make much difference. Number 7. Would you like me to make that a little bigger for you to see? Let's see if I can. That might help just a little bit. I probably can't keep the conversion facts on the screen, but hopefully you don't need them. All right, number 7. Let's change 32 ounces to grams. Now, we're going to do this. In a physics class, we would not do this because 32 ounces, in our system, an ounce is a unit of weight. A gram is not a unit of weight. So in reality, you shouldn't convert those two. They don't measure the same thing. But in everyday conversation, we treat grams like they're units of weight. I won't say that again. I'll be quiet about that. I have a little bit of a physics background, and so it literally drives me crazy that we do that. I will keep it to myself though. All right, first thing I need to do, anytime the US or English system is involved, is I have to have a fact. And my fact is that 1 ounce is approximately 28 grams. All right, so how do I do dimensional analysis? I take 32 ounces, I put it over 1, I multiply it by, okay, my fact, 1 ounce is 28 grams. What goes on the bottom? Yes, 1 ounce. And on top has to be the 28 grams. Please, please write those units down. That's another thing that is a carryover from a little bit of a physics background, is that numbers without their units are naked. And they have to have their units if there are units. All right, so ounces to cancel out. I'm all good. I need to multiply 32 times 28, and I'll just ask my calculator to do that for me. I get 896. 1 times 1 is 1. I'm not going to write that as a denominator. I have 896 grams. So 32 ounces is the same as 896 grams. All right, I think I'm going to just take a quick look at the next two problems, but I don't think we necessarily need to do them in class. They are done on the lecture notes, but they won't be part of this recording. It has 420 pounds to kilograms. US system, metric system. That means I have to do dimensional analysis. Do we have a pounds and kilograms conversion fact? The answer is yes, and we would use that. Does anybody in class have a question about how you would proceed? I don't mind doing it if you want me to, but I'm not going to bore you with it if this is, we'll start with our 420, I will do just a minute of it. That's how I start. When I write the conversion fact, what goes on bottom? Yes, 1 pound, because I want the pound to cancel out. And then that means on top is 0.45 kilograms. So blah, blah, blah. That problem could be finished. All right. Problem number 9, changing pounds to grams. Now remember, grams are tiny. Gram that's the weight of a paper clip. So let's look. I think we will do this problem. I did the problem and got an answer that did not match what was printed out from the computer, and I was kind of worried about it, so I went into the problem and actually did it, and I did it 2 different ways. Because of rounding in the conversion fact, I got 2 close but slightly different answers, and it counted them both right. So I double checked that. I'm going to shrink this just because it's very important to have these facts visible. Let's look at this. We're supposed to change pounds to grams. Is there a fact sitting over here, pounds to grams? No. Okay. What 2 facts, or at least a fact and a slide scale, what could I convert? What could I turn the 45 pounds into? Pardon me? Ounces. You know, that's exactly how the textbook did it. That wasn't what I did. That's what the textbook did, though. They changed the 45 pounds into ounces. So let's do that. 45 pounds over 1. I'm going to use this fact, and I need 1 pound, and I need 16 ounces. Now, before I stop, when we finish this, if you look up here for a second, and you notice that, of course, the pounds will go, whatever that answer is right now, it's in ounces. Can I then change ounces to grams? Yes, I have to use a second fact. So I'm just going to go ahead and tag one on here. I'm going to multiply by 1 more. I have ounces. I don't want ounces, so I put 1 ounce down here, and I put 28 grams up here, and those are gone. I need to multiply 45 times 16 times 28, and the only unit left will be grams. So if I use my calculator to do that, 45 times 16 times 28, I get 20160, 20,160. The only unit left is grams. So, Sam, you saw exactly what the author of the book did. And that was not the route I took. I'm not going to make you see mine. If you look at the notes, you will see it. In fact, I could, I'm not going to be showing it on the video. I used the fact that was changed pounds to kilograms. So I changed my pounds with that fact to kilograms. Then I used the slide scale to change my kilograms to grams. But you might be able to see I got 20,250. Whereas in class, in this recording, it's different. And so I was very concerned that my math lab would, it wouldn't know which way you did it. They're both valid. Would it count one of them wrong? And the answer is no. I did the problem twice, and I went one time through ounces and one time I went to kilograms and then slid the decimal point. I got answers and it said good job on both of them. So it is programmed to accept either one. They are different. I mean, they should be the same. But in these facts over here, you see where it says approximately? That's what did it. And you know what? I should have not gone that route because of that approximate thing. No, wait, let me back up. Either way, you're going to use approximate. That was the way that y'all went. I went this way. It didn't matter, but it is that approximation. They have been rounded differently, so you're going to get a little error. Okay? So, do y'all feel comfortable with conversions? We're about done with conversions. Not going to torture you with it anymore. Metric system, moving decimal points around, customary US, British system, English system, whatever you want to call it, you have to use dimensional analysis. And dimensional analysis is used in other areas. Suppose that you had a rate of speed. You said, oh, he's driving 55 miles per hour. And yet in physics, many times rates of speed need to be in feet per second. And so you would use dimensional analysis to change that. Very, very powerful. All right, moving on. We're going to do temperature conversions. This particular little screenshot is of a thermometer that has both the Fahrenheit scale and the Celsius scale. And the thing that I'd like you to notice is, first of all, their zeros are in different places. The size of units is different. Can you see that these over here, these Fahrenheit degrees, they're slightly bigger? And I don't mean the tick marks are bigger. The actual distance between the degrees is slightly bigger. A degree in Fahrenheit, I just said that backwards. A degree in Fahrenheit is actually smaller. Maybe I guess these are counting by, oh, they're counting by twos. That's why I said that wrong. These are actually from here to here is 20. So from here to here is 10, and that's smaller than 10. All right, here's the deal that I want you to recognize. This figure is clearer. There are 3 temperature scales. Fahrenheit is used in the United States most frequently, except in technical settings. The Celsius scale is more of a metric scale and used probably more universally. Why is it a metric scale? From freezing to boiling is 100 degrees. What's going on in our scale? 32 is freezing. 212 is boiling. So there's a lot more degrees here, and that means they have to be smaller. We don't really have to talk too much about absolute zero, but absolute zero is the temperature at which molecular motion stops. So we know that water freezes, it becomes solid. It's solid, but inside those water molecules, there is still motion going on. If you ever get something cold enough to be absolute zero, molecular motion stops. All right, so that's the big deal over here, is that we go from 32 to 212. They go from 0 to 100. How nice is that? There's that 100 again, that power of 10. Now Kelvin, this is just a scientific scale. It starts 0 at absolute 0 and then goes from there. Regular, everyday folks don't use the Kelvin scale. The scientists use the Kelvin scale some. All right, moving on. We need to be able to switch between these. I think exclusively in the Fahrenheit scale. It is probably a feature of my age. I have been exposed to the metric system enough that I sort of have a feel for many of the measurements. I don't have a feel for the Celsius scale. Meaning if you told me it is 45 degrees Celsius, I really don't know how hot or cold it is. I don't think Celsius. I can convert. It would be great if I could think it. All right, these two formulas are on your, they are somewhere. They're on your conversion packet at the bottom. You notice that if you have Celsius, you take 9/5 of it, and then you add 32. If you have Fahrenheit, first you subtract 32, and then you multiply by the reciprocal, which is 5/9. The 9/5 and the 5/9 takes into account the fact that the degree sizes are different. Fahrenheit has little degrees and Celsius has bigger. Where does this plus 32 and minus 32, where do you think that comes from? Fahrenheit. Where does water freeze in Fahrenheit? 32. So what it does is it either shifts it down to 0 or it shifts it up to 32 depending on which way you're going. So that's where that comes in. Let's do a few of these. These are a matter of, can you use a formula? And can you use the right formula? Let's look at number 10. Convert the given Celsius temperature to its equivalent temperature on the Fahrenheit scale. And it must say something else. And then it goes on, round to the nearest 1/10 of a degree. One way the numbers turn out nice, and the other way they don't turn out very nice. Depends on which way you're going. All right, we've got the Celsius. We're moving to the Fahrenheit. We want Fahrenheit. So we're going to say, we're going to choose the formula. Fahrenheit is equal to 9/5 Celsius plus 32. So you have to grab the right one. We're going to plug in the 27 we were given. F is equal to 9/5 times 27 plus 32. Now, how many of you have your TI 83 or 84 already? Do you have it with you? You do? No? Oh, okay. All right. Well, this can be done pretty easily on the grapher. So I'm going to be off video for a second. Because I'm going to type this in exactly as I see it. I've got 9 divided by 5 times 27 plus 32. Now, this is going to work because of order of operations. Please excuse my dear Aunt Sally. It will take the 9 and divide it by 5 and get a value. Multiply that by 27 because it's going left to right with division and multiplication, and then add 32. Drum roll, you hit enter, and you get 80.6. Okay, if you don't have this calculator, then you're going to multiply 9 times 27, divide it by 5, and then add 32. You have to take care of order of operations. Or you could say 9 divided by 5, whatever you get, times 27, whatever you get, plus 32. You can go left to right. With any scientific calculator, it'd be fine. All right, let me switch back. All right, this is degrees Fahrenheit. So, see, I don't think Celsius. If somebody said, It's 27 degrees Celsius outside. It's 80 degrees Fahrenheit. It's a rather nice but warm day. So I don't think that yet. All right, let's do one more where we're given Celsius. We have Fahrenheit is equal to 9/5 Celsius plus 32. So it is 9/5 times 51 plus 32. So I won't go off camera to do this. I'll just do it. I have 9/5 times 51 plus 32. And I think I may have, whoops, I don't even know which problem I'm on. Oh, I got 123.8. This is degrees Celsius. Degrees Fahrenheit. Did I write the wrong thing on that? No, I was okay. So it's 51 degrees Celsius. Oh my goodness. We can't survive in that outside. 123 degrees. Maybe in some deserts it gets that hot. All right. Let's skip number 12. Although we probably should do 12. I'm just going to tell you what the answer is. It is 98.6 degrees Fahrenheit. Is that a significant measurement to you? 98.6? Isn't that the Fahrenheit temperature for healthy human body? That's our temperature, our body temperature. So if you were dealing in Celsius, you would say, oh, I measured her temperature and it was 37 degrees. That's good. That's healthy. That doesn't indicate infection. If the temperature rises in Celsius, if it goes to 38 or 39, that's of more concern because those degrees are bigger. So that's actually getting a lot hotter. All right, let's do just a couple in the other, going the other way. Now we're looking for a Celsius. So I'm going to use the formula. C is equal to 5/9 Fahrenheit minus 32. You have to use parentheses. And you can use them if you're using your TI-83 or 4 calculator. So C is equal to 5/9 parentheses 65 minus 32. If you're doing this without this special calculator, you probably need to go ahead and do the order of operations yourself. Do your parentheses. In other words, do 65 minus 32, and whatever you get, you're going to multiply it by 5 and divide it by 9. But I get to type this in exactly as I see it. So 5 divided by 9, open parentheses, 65 minus 32, close parentheses. And I get 18.3333 degrees Fahrenheit. The instructions tell me to round to the nearest tenth of a degree. So this is going to be approximately 18.3 degrees Fahrenheit. Whoops. Please fix that. I was converting to Celsius. It said C equals, so that was a bad mistake on my part. It is degrees Celsius. So when it's 65 degrees outside, maybe it's a nice fall evening, it would be 18.3 degrees Celsius. And I have trouble wrapping my mind around that. I just think Fahrenheit. When I hear 18.3 degrees, that's below freezing in my mind because I'm thinking in the wrong scale. All right. There are a handful of problems for you to work on that. They're all on the lecture notes. Does anybody have any questions or want to spend any more time on that? Are we good? Okay, so you're going to convert weight quantities and you're going to convert temperature. So I'll go ahead and stop this video.